In the workshop, and this is part 4, fitting a mechanical lubricator to a Stuart 5A steam engine with valve timing problems. You will notice that I did say part 4 and not part 14 because I made a mistake in the last one. People couldn't wait to tell me about this, so yes, I am aware that I said it was episode 13 and not episode 3, so to put the record straight, this is episode 4, not episode 14. This series started out being about fitting a mechanical lubricator to a 5A steam engine, but unfortunately I found out that the valve timing is a bit wrong on this engine, and here you can see why. When I first fitted the reversing gear it worked perfectly, but the positions of the nuts have moved. A Stuart 5A valve is held in position by a nut either side of it, and these nuts normally have lock nuts fitted, but it's not so on this particular engine. And also, once I fitted the mechanical lubricator, I found out there was a problem with it. When I turn it over like this using a socket, then obviously it works. But when it's under its own ratchet power, it works for most of the time, and then it will suddenly stop in the same place. In this clip, I'm rotating the oil pump, and as you can see, it's pumping oil quite well. It's all pouring into the steam chest. Before I get any questions, I would just like to say that even though the oil enters the steam chest at the bottom, when the engine is running on steam or compressed air, the oil goes everywhere, all over the valve, along the ports, into the cylinder, where it does what it's supposed to do, lubricates the cylinder. What I'm doing at the moment is tightening down a couple of bolts to make sure that the steam chest is held firmly to the port face. I need to accurately retime this engine, so it's a good idea that the steam chest doesn't wobble about all over the place. I don't think I'm going to bother with the lock nuts because personally I find them a pain on 5As. They're quite difficult to adjust and they can still work loose. I'm going to use a different method and I'll show that later on. The first thing I need to do is set both of the eccentrics at 90 degrees to the crank webs, but at opposite ends of the crank web for both eccentrics. Then starting with the lever being at the bottom of the slot, I rotate the flywheel in the direction that it would be going with the lever at the bottom of the slot, and I take note of where the actual valve is on the port face. The slide valve needs to uncover the port openings exactly the same at both ends, and it's very important to continuously turn the flywheel in the correct direction. That way you're not fighting against any backlash in the system. This can take quite a while and it's very difficult to show on the video, but the port needs to just crack open as the slide valve passes over it, and it needs to do this exactly the same at both ends. In this clip I have the setting that works perfectly with the lever in both positions at the top and the bottom. And now I'm using a centre punch, and I'm using it very gently to make a couple of pop marks just where the nuts meet the thread. And now when I try and undo the nuts, they will still undo, but they become tight very quickly. But it's still not impossible to remove them. This is not a massive problem at all. The centre pop marks just stop the nut from working loose and working its way down the thread. It's worth mentioning that I made the pop marks with both of the nuts tightened, and then I slackened them off a bit, both of them, because the slide valve needs to float. And now to make doubly sure, another tap with the centre punch. Now the valve is in the correct position entirely. With that job out of the way, it's time to make a gasket. As you can see, I've used this piece of gasket material before to demonstrate the ink pad method of marking out components. But I'm trying a different method now. I'm going to use one of these transfer punches to transfer the holes in the steam chest cover to the gasket material. Sometimes I use a thinned out pencil. Sometimes I use a steam chest cover or cylinder cover as a guide to drill holes straight through the gasket material, but this time I'm doing it a different way just for a change. Once the positions for these holes have been marked, I used a hole punch and very carefully punched them out, followed by cutting the gasket somewhat oversized, as you can see here. And now the gasket is cut out, I can continue with the hole punch and work all the way around. Note to self, it's about time I cleaned out the punch part of this hole punch because the column is getting very solid with bits of gasket material. And I really did have to apply too much pressure to punch these holes. I need to clean it out. But nevertheless, here is the gasket fitted to the engine. Now I could just use it like this, but I never like to leave the centre part in place because over time it gets a bit soggy and it can get very slack and break up and then go into the engine. Not doing a great deal of damage, just making the engine run a bit weird for a while. So here I'm cutting out the centre section using a scalpel. And not a very sharp scalpel at that. I think I need to change the blade. But it's sharp enough to cut a nice neat hole in the centre of this gasket material, so that the gasket matches the steam chest. A quick clean up of the front of the steam chest cover, and I'm now going to refit this to the steam chest itself. Thanks to the miracle of video, I don't have to show me refitting all the nuts to the studs. Once I'd refitted the nuts to the studs though, I did use the scalpel to tidy up the outside edge of the gasket material. Once I'd done this, I connected the airline to the engine and admitted some compressed air. Well, it's not bad that way, it needs a bit of adjustment. And it's not bad going the other way, it sounds about the same. I turned the pressure up as well. If you look at the mechanical lubricator, you will see that it stops at a certain part of its travel. If you watch how it rotates, you will see that it stops in this position each time. I think this is because there's something wrong with the ratchet, or the positioning of the ratchet relative to the pawl. I went up to Blackgates Engineering and Matt gave me a new assembly to fit. I'll be making a video about that very shortly, showing exactly how these things work and how they're put together. Sometimes it starts up again. I could fix this easily by moving the lever onto the next hole in the actuating arm, but then it would over lubricate and I don't want it to do that. And it's just annoying to see it always struggling in this position. Correct cylinder lubrication is a must because the engine will be ruined if lubrication to the cylinder is halted during a run. Don't forget, this is not a small Mammoth engine, this is a full-size small engine and it runs on very high temperature superheated steam. One viewer wrote in and mentioned maybe it's because you haven't filled the tank full enough. So just to keep this viewer happy, I'm putting quite a lot of oil in the tank. It won't make any difference, but I do like to keep my viewers happy. And that's about it for this video. I'm just going to say thanks for watching and I hope you found it useful, and leave the engine running in slow motion until the end. This is a video running at 10% of the normal speed.